You know, we always talk about the sun being this like big ball of burning gas millions of miles away.
Right.
But sometimes it really makes its presence known here on Earth.
Yeah.
And we saw that happen just a couple days ago, actually, on October 23rd, with a massive solar flare.
It was.
And we actually have pictures of it thanks to NASA.
Yeah, a huge solar flare. It was classified as an X3.3, which is like the most intense category they have.
Whoa. Okay, so this is serious stuff, but what does that mean for us here on Earth?
Well, it might seem like a huge distance, but the sun's influence goes way beyond its surface.
Oh.
You know?
Okay.
We're talking about space weather here. All the, like, energetic particles and radiation that the sun sends our way.
So space weather, it's not just like a cool name. It actually affects us.
Oh, yeah, absolutely.
Yeah.
Think about it. Our world depends on technology, like, all the time now.
Yeah.
Right? Like communication networks, GPS, even the power grid.
Yeah, true.
All those things can be disrupted by the radiation and electromagnetic pulses that come from a solar flare.
So this isn't just about pretty pictures from space. This could actually impact our everyday life.
Exactly.
So what makes these X-class flares so powerful? I know we hear about like C-class and M-class too.
Yeah, you can think of it like the Richter scale, you know, for earthquakes.
Right, yeah.
Each letter is like a 10-fold increase in energy output.
Yeah.
So C-class flares are pretty common and usually don't have much impact.
Gotcha.
M-class is stronger. We might see some radio disruptions with those.
Uh-huh.
But the X-class, those are the big ones. They can release energy like billions of atomic bombs all at once.
Billions. That's insane. And we saw this one happen. We actually captured it on camera.
Yeah, we did, thanks to NASA's Solar Dynamics Observatory, or SDO.
Okay.
It's been orbiting the sun since 2010, keeping an eye on things. Basically, our sentinel in space watching the sun's every move.
That's pretty cool. So what makes SDO so special?
It takes high-res images and collects data across all different wavelengths. So we're not just seeing like a flat picture. We get this multifaceted view of what's happening on the sun's surface and its atmosphere.
That's amazing. So let's go back to this specific X-class flare. What happened and why should we care?
Well, this X3.3 flare, it erupted from a superactive region on the sun.
Okay.
A region with sunspots, those cooler, darker areas that tell us there's intense magnetic activity going on.
Right.
Sunspots are like pressure valves for the sun's magnetic field. And when all that pressure builds up and releases, bam, you get a solar flare.
So we've got these sunspots building up energy like a coiled spring.
Yeah.
And then all of a sudden a solar flare erupts. What are the real-world consequences of something like that?
Well, the good news is Earth's magnetic field and atmosphere protect us. They absorb a lot of that harmful radiation.
Oh, hey, that's good.
But it depends on the intensity and direction of the flare. There can definitely be noticeable effects.
Like what?
We've seen disruptions to radio communications, GPS systems, and even power grids in the past.
Wait, so you're saying a solar flare could actually cause a blackout?
It's happened before. And
Yeah.
think about it. We rely on technology more than ever now.
Yeah, that's true.
So the potential for disruption even greater today. There's actually a historical event that shows just how powerful these solar storms can be. It's called the Carrington event.
Okay, the Carrington event. What happened there?
Well, back in 1859, this huge solar storm, way bigger than anything we've seen, recently slammed into Earth.
Wow.
It totally messed up the telegraph systems.
Really?
Yeah, they were like the high-tech thing back then, and operators were saying sparks were flying from their equipment. Some even got electric shocks.
Oh, wow.
There were even reports of telegraph paper catching fire.
So even back then, before we were so reliant on electronics, a solar storm could cause major problems.
Oh, yeah, absolutely. And if the Carrington level event happened today, the consequences would be way worse. Imagine global communications, financial systems, transportation, all disrupted.
It's kind of scary to think about how vulnerable we are to something we can't even see.
I know, it's true. That's why it's so important to understand space weather and how these solar events can impact us. We can't control the sun, but we can try to minimize the risks.
So what can we do?
There's a lot of research going on to improve space weather forecasting, early warning systems, and designing tougher infrastructure.
So we're not just sitting ducks waiting for the next big solar storm.
Nope, not at all. And technology like the Solar Dynamics Observatory is playing a big role in protecting us.
How so?
The data SDO collects helps us understand how the sun behaves track solar activity and make those forecasting models better so we can be more prepared.
So SDO is like our eyes on the sun giving us a heads up about potential trouble.
Exactly.
So what can we do to prepare ourselves?
Well, on a bigger level, it's about investing in stronger infrastructure backup systems and having protocols in place for when disruptions happen.
Makes sense.
For individuals, it's about being aware and having a plan, just like you would for any other natural disaster.
Okay. Stay informed, have a plan. So practically speaking, what does that mean?
Well, thinking about what you'd do if the power went out or you lost communication is a good start.
Okay.
Having some backup power, keeping your devices charged, finding other ways to get information, those are all good steps.
So being prepared, not panicked, right?
Right, exactly.
But how likely is it that we'll see another Carrington-level event?
It's tough to say for sure, but scientists think there's a small chance it could happen in our lifetime.
Okay, well, that's a little unsettling, but it also shows how important all this research and preparedness is.
Definitely. And it's not just about protecting our technology. Strong solar storms can be dangerous to astronauts in space and even mess with satellites.
Wow, we started by talking about a cool picture of a solar flare, and now we're talking about potential blackouts, disrupted communications, and risks to astronauts. It really makes you think.
Yeah, it's a good reminder that we're part of a much bigger system here.
And that system is dominated by the sun, the source of our energy, the driver of our climate, and a force we need to respect.
For sure.
So where do we go from here? What can we as individuals do with this information? It's a lot to take in.
That's a great question, and it's one that scientists and policymakers are working on right now. But for you and me, awareness is key. Understanding that space weather is a real thing and that it can affect us. That's the first step.
Okay, so be aware. What else? Should I be building a solar flare bunker in my backyard?
A bunker might be a bit much. But staying informed about potential solar storms is a good idea. There are websites and apps that track solar activity and send alerts.
Oh, cool.
You can also follow organizations like NOAA's Space Weather Prediction Center. They've got all the latest updates and info.
So if I see a news alert about a big solar flare, should I start stocking up on canned goods and duct tape?
Probably not to that extent, but just like with any other natural disaster, having a plan is always smart. Think about what you'd do if you lost power or communication.
Makes sense. Be prepared, stay informed. Good advice for life in general, not just for solar flares.
You got it. And remember, this isn't about being afraid of the sun. It's about understanding its power and how it can impact our lives. We've enjoyed the sun's energy for a long time. Now we're just figuring out how to deal with its occasional tantrums.
This deep dive has been amazing. From those incredible SDO images to the potential fallout of a major solar storm, it really highlights the powerful forces out there and the importance of science.
I agree. And, thinking about the bigger picture, it really shows how crucial scientific observation and research are for keeping our world safe.
Yeah, for sure.
It's incredible that we have a satellite millions of miles away watching the sun and sending us data that helps us understand and prepare for these potentially disruptive events.
That is mind-blowing, and it makes you wonder what other discoveries are waiting to be made out there.
That's the beauty of science. It's all about exploring, and each new thing we learn opens up a whole new world of possibilities and maybe a few challenges along the way.
Speaking of challenges, I think you've left our listeners with a big one to think about.
I have. As we depend more and more on technology that's vulnerable to space weather, what should we be doing as a society to get ready for even stronger solar events in the future?
Yeah.
That's a question for all of us, not just scientists and engineers.
Definitely something to think about. And a great place to wrap up our deep dive into this amazing solar flare.
I encourage everyone to check out the full article and those incredible images from NASA's SDO. It's a glimpse into the power and beauty of our sun and a reminder of our place in this vast and amazing universe.
And until next time, keep looking up and keep exploring. It's a lot to wrap your head around, isn't it? Like, we talk about prepping for earthquakes or hurricanes, but space weather is a whole other ballgame.
It really is.
Yeah?
And most people don't think about it much.
Huh.
But the more we rely on technology, the more vulnerable we become to these solar events.
So what can we do about it? Are we talking about, like, some global effort to make our infrastructure tougher?
Well, there are definitely people working on that. Power grids, for example, can be designed to prevent those big widespread outages. And satellite systems can be built with special shielding to handle the radiation.
It sounds like a huge project, though. Like, where do you even start?
Awareness is key, which is what we're doing here right now. The first step is recognizing the threat. Then it takes collaboration, governments, scientists, engineers, even private companies all working together.
It's like a global challenge, almost like climate change. But instead of emissions, we're dealing with solar flares.
Yeah, that's a good comparison. And just like with climate change, there's no easy fix. It's going to take research innovation and a commitment to making things more resilient.
It's a little daunting when you think about it, but it's also kind of hopeful. Like, if we can put a rover on Mars, we can figure out how to protect ourselves from solar storms, right?
Exactly. That human ingenuity always finds a way. And we're making progress. We're getting better at understanding and predicting space weather, developing technologies to minimize the risks. It's a process, for sure, but we're moving in the right direction.
This whole conversation has really changed how I see things. It's not just about those amazing pictures of the sun. It's about understanding how connected we are to it, how it gives us life, but also has the power to disrupt our world.
That connection is really at the core of it all. And the more we learn about the sun, the more we learn about ourselves and our place in the universe.
You've definitely given us a lot to think about today. From the science behind solar flares to what it means for our tech-driven world, it's been a fascinating deep dive.
I agree. And as always, I encourage everyone to keep learning about this stuff. Check out the full article we talked about, look at those incredible images from NASA's SDO, and stay curious about the wonders and challenges of space weather.
Absolutely. And until next time, keep looking up, keep learning, and maybe keep a flashlight handy just in case.